Welcome to the BioWhisperer channel. Our topic today is on a perspective overview of the machine learning and its applications. If you are new here, we are a group of retired professors sharing bite-sized videos in life sciences. Introduction to machine learning. It's taken decades, but as of today, on its simplest implementations, machine learning applications can do some tasks better and/or faster than humans. Machine learning is most advanced and widely applied today in processing text through natural language processing, followed by understanding images and videos using analytics and anomaly detection. Over the past decade, machine learning has exhibited key capabilities in understanding and mapping patterns of interest in all sorts of signal data faster and more reliably than human operators, with widespread adoption in commerce and finance sectors. Firstly, some definitions and terminologies to get the basics across. Data scientists are the researchers of data science are responsible for extracting insights that help businesses make decisions. They explore and analyze data using machine learning platforms to create models about customers, processes, risks, or whatever they're trying to predict. Artificial intelligence or AI refers to the catch-all term used to describe intelligent machines, which can solve problems, make or suggest decisions and perform tasks that have traditionally required humans to do. AI is seen as a constellation of different technologies. Next, let's look at machine learning and what is it? Machine learning is considered a subfield of artificial intelligence. Scientists combine data with algorithms optimized towards training a model using the data. The progressive training of the model will enable it to then make predications on new data or the decision-making processes, such as understanding text and images, without being explicitly programmed to do so. The learning part of machine learning means these programs change how they process data over time. In other words, a machine learning algorithm can adjust its own settings, given feedback on its previous performance in making predictions about a collection of data. Machine learning exhibits the various capabilities. First, the ability to recognize and understand text, natural language processing, which is associated with the application of computational techniques to the analysis and synthesis of natural language and speech. Next, the ability to write human-like answers to questions and assist in writing computer code. Third, being able to recognize and understand images and video streams where its ability to detect changes in patterns or in recognizing anomalies have permitted its application in recommender engines such as for social media or e-commerce shopping suggestions. We are seeing some of these applications in phone software, in smart home hub or platforms with the ability to react and respond to our queries. Moreover, machine learning with artificial intelligence is able to leverage deep natural language processing, text analysis, and computational linguistics to gain insight into customer opinion, understanding of consumer sentiment, and measuring the impact of marketing strategies. This is often deployed for sentiment analyses. We will next examine the key activities associated with machine learning are as follows. Firstly, to understand the gap or problem to address and from the dataset given, to provide an attempt to discover and define high-level structure and create a roadmap for discovering potential data sources. Second, to gather data which facilitate in building data pipelines towards data exploration. To set up development environments to access and migrate raw data or to generate synthetic data. Third, to set up machine learning and perform model development and testing, with refinements and optimization along the way. Next, the aim is to set up the scale to production with the QC and QA of the proposed model implementation. Often automating the machine learning workflow is critical with ongoing testing and assessment on the integration with existing staging and production environment required. The last key activity is to maintain the model and provide improvement and continuous refinements where need. Putting together key information and knowledge on the modeling into a governance cheat sheet will be an administrative closure to the machine learning project. Within each stage there are also key challenges. For instance, during the understanding of the data requirements to support the KPI or business problem definition, the data scientist may face issues with business problem ambiguity as well as data availability. It is about finding the right starting point for a smooth transition towards gathering of data. During data acquisition, one may face access issues to the client's data locality, quality as well as security and permissions considerations. In building the proof of concept, the data scientist may have to work within a restricted environment with team locality requirements along with any contractual obligations or regulatory compliance required. During the scale to production, the data scientist might be challenged with the needs to assess testing of non-deterministic systems as well as issues such as complexity of legacy systems, feedback and governance bottlenecks with the client stakeholders. This might result in performance declination in the production environment with a slow and complex change management process or a lack of support in place. In a nutshell, the main challenge in machine learning lays in preparing the simulation environment, which is highly dependent on the task to be performed. Transferring the model out of the training environment and into the real world is where things get tricky. Often, scaling and tweaking the neural network controlling the agent is another challenge. Within the field of machine learning, there are three main types of tasks: mainly supervised, and unsupervised learning as well as reinforcement learning. The main difference between the first two types, namely supervised and unsupervised learning, is that supervised learning is done using a ground truth, meaning that it is important for data scientists to have prior knowledge of what the output values for their samples should be. Automated analysis software can be separated into two groups based on the learning paradigm according to supervised and unsupervised. To create a coding application based on supervised learning, information about behavior is taught to computers using specific instances of classification, which is assigned a name or label. Unsupervised learning is split into two subgroups, namely clustering and dimensional reduction. For the clustering subgroup, social media and technology companies are currently actively using it for recommendation systems. For businesses, it is used in areas of targeted marketing as well as for customer segmentation purposes. For instance, a specific pattern of shopper purchases at an e-commerce store can trigger the unsupervised clustering to provide more inline recommendations of similar categories of products. For the subgroup on dimensionally reduction approach, it concerns the recognition of features, traits, patterns of data and to consolidate them into a structured frame. It is commonly used in big data visualization and aims to tap on structure discovery to highlight and observe features, elicit these features and to have meaningful categorization of the data patterns. Often meaningful compression would be utilized as part of the dimensionally reduction strategy to make unstructured data become more sensible and then to further sort and analyze in bins or categories. Supervised machine learning applies to situations where data scientists have some idea or knowledge regarding the outcome of your input data. For instance, if the scientists want to create an image classification machine learning algorithm that can detect images of planes. To train the AI model, you must gather a large dataset of airplane photos. But before feeding them to the machine learning algorithm, there is often the laborious manual task where the data scientists have to annotate them with the name of their respective classes. Annotation might include putting the images of each class in a separate folder, using a file naming convention, or appending metadata to the image file. Once the data is labeled, the machine learning algorithm could process the examples and develops a mathematical model that can map each image to its correct class. If the AI model is trained on enough labeled examples, it will be able to accurately detect the class of new images that contain various airplanes. Typical common supervised learning algorithms include linear and logistic regression, the naive Bayes, the use of support vector machines, deployment of decision trees and random forests as well as the use of artificial neural networks. Supervised machine learning strategies are deployed in areas of classification and regression sub-strategies and provides insights on process optimization, forecasting predictions and even in areas of fraud detection and diagnostics of system processes. One of the benefits of unsupervised learning is that it doesn't require the laborious data labeling process that supervised learning must go through. However, the trade-off is that evaluating the effectiveness of its performance is also very difficult. In contrast, it's very easy to measure the accuracy of supervised learning algorithms by comparing their output to the actual labels of their test data. Reinforcement learning is a machine learning training method based on rewarding desired behaviors and/or punishing undesired ones. In general, a reinforcement learning agent is able to perceive and interpret its environment, take actions and learn through trial and error. Taken simply, it revolves around training machine learning models to make a sequence of decisions based on a reward policy set by the data scientist. In reinforcement learning, the artificial intelligence of the machine learning faces a game-like situation. The computer employs trial and error to come up with a solution to the problem. To get the machine to do what the programmer wants, the artificial intelligence gets either rewards or penalties for the actions it performs. Its goal is to maximize the total reward whilst solving the game. By leveraging the power of search and many trials, reinforcement learning is currently the most effective way to hint machines' creativity. In contrast to human beings, artificial intelligence can gather experience from thousands of parallel gameplay and improve on its speed and performance. Reinforcement learning is often used in real-time decisions, learning tasks and skill acquisition as well as in robotics navigation. The fields of machine learning, deep learning, and artificial intelligence are rapidly expanding and are likely to continue to do so for the foreseeable future. There are many driving forces for this, as briefly captured in this overview. In some cases, the progress has been obviously dramatic, opening new approaches to long-standing technology challenges, such as advances in computer vision and image analysis. With the data trending pointing towards widespread adoption of assistive technology such as machine learning, there are some key trends that facilitate greatly towards the adoption of machine learning. These are firstly massive datasets, followed by the need for improved and continuously refined machine learning algorithms in an attempt to understand the datasets. Often this is supported by open source codes with community participation. The use of pre-trained models and frameworks are also supportive towards the integration of machine learning into coding processes. Finally, this is going to demand ever-increasing and higher computing power to facilitate all the integration. Taken together, this will take a combination of high-performance computing, advanced artificial intelligence and machine learning chips or associated semiconductors, more systemic creative machine learning implementations and decision science framework to make machine learning of tomorrow even better than today's.
We hope you have enjoyed our sharing and see you in the next video. We would thank you for helping to share your love for this science channel by clicking the like button and subscribe for future updates.